Welcome back. We are here today to talk about lines, angles, perpendicular, parallel. We'll get to all those. We're going to start off first with just plain old line. What is a line? Well, a line is something that goes on in both directions forever and ever and has no endpoints. It may have some points here on a line, but it just keeps going in one direction and the other direction in two ways forever. Never ever stops. So that would be an example of a line right there. Let's go down to the line segment. A line segment is something that has two endpoints. Think of it as that thing that starts and stops with two endpoints, and it does not continue on forever and ever. It just has two endpoints, so it starts and it stops, and it doesn't keep going. Let's look at the next, which is over here on the side. It's going to be a ray. A ray has one endpoint, and it goes on in one direction forever. Again, ray has one endpoint and goes one direction forever. So these would all be examples of rays in this section here. Now next, let's talk about what makes lines and rays important for us to know, and it helps us a lot with angles. And let's just draw this angle here. And if you notice, this section right here, this angle, is formed by one ray right here and a second ray right here. So two rays put together can form an angle. And by the way, this little point right here is called a vertex. Think of a vertex as if you draw a hand, somebody's arm right here, and you know that there's an elbow. Think of that vertex like someone's elbow. That would be the vertex. Now, that's not the only way an angle can form. An angle can also form with two line segments. And we know that here's our angle. It still has one vertex, and it has a line segment and another line segment. So one line segment, two line segments. This is now an angle. This one right here is also an angle, and it's a special angle we're going to talk about just here in a minute, but it has one vertex right there. And remember that elbow right up there, the elbow, it makes that the vertex. Now let's talk about two line segments coming together to form an angle, or two rays coming together to form an angle. We have our vertex right here, and this one has a square angle, or another way of thinking of it is 90 degrees. And I wonder if you know what a 90-degree angle is, and if you guessed a right angle, you are correct. This is called a right angle. When two rays or line segments come together and they form a 90 degree, or you could think of it as a perfect L shape, that will be a right angle. Now let's take a look at another angle that's really important to remember. And it's going to be, and if you guessed less than 90 degrees, you would be correct. This is an acute angle. And you can kind of think of, oh, look at how cute that little angle is. You know, think of your little baby cousin or your little brother that's 3-4 months old. It's nice and cute. Oh, you think about less than 90 degrees. If it is less than 90 degrees, then it would definitely be acute. If it's equal to 90 degrees, we know it's right angle. Well, last angle we're going to talk about here, and this isn't the last type of angle that's possible, but it's the last one we're going to talk about today. We're going to talk about, now I don't really like that color. Let's try a different color here. And I'm going to erase that. Let's pick a new this one we're going to draw what looks like greater than a 90-degree angle. It is greater than 90 degrees. Wonder what kind of an angle this would be. If you guessed obtuse angle, you are correct. Obtuse angle. Very important. Very important terms to remember. Right angles right angle is equal to 90 degrees. An acute angle is the one that's less than 90, and obtuse is the one that's greater than 90 degrees. All right, we're going to get into one final topic, talking about lines, line segments, angles, and things. This is perpendicular or parallel. Play a little game here. We're going to look at these and decide perpendicular or parallel. Well, first, let's talk about what does that mean. Perpendicular. Anytime two lines or line segments meet and form a 90-degree angle, that is perpendicular. Parallel are two lines running the same distance between each other no matter where you take that measurement. So any spot on two line segments, wherever you measure, they should always be the equal distance apart and never get closer and never get farther apart from each other. So let's take a look. Right here, our first one, we have two rays. We have an end point here, and it goes in one direction forever. We have an end point on one side, it goes in one direction forever on that side. These, notice between these, equal distance apart. They never get any closer, never any farther apart. These would be parallel to each other. Okay, let's go down here we'll go over here to the side. We have two lines over here. Remember, a line goes in both directions. In both directions forever and never, has two endpoints. So we go right here and we say, is this the same distance as the middle? Yes, it is. Is this equal distance on the end? Yes, it is. Is this equal distance? No matter where we went, if we extended these lines on forever, they would never get closer to each other. They would never become farther apart. They would always stay in the equal distance. So these would be considered parallel as well. Parallel. All right. Now let's go to this one right here. I see two line segments. So we're going to number this number 3, two line segments. But I do see a problem on this one. We know that distance, and then look at how small the distance is at the top. It gradually gets smaller. So these would not be parallel or perpendicular. Let's go down to the bottom example. And I see the way this crosses, and it kind of reminds me of a plus sign in math, and it forms right angles. So notice this right here is forming a right angle. So anytime two line segments or lines or rays intersect, forming a 90-degree angle, those are perpendicular. Perpendicular lines. Now let's go up here to the top, right up here, our fifth pair, and these look like two line segments. And I'm going to look, the distance between here and here looks the same. The distance here, those are parallel to each other. And don't be confused, even though you see what looks like a short line segment versus a long. It doesn't have anything to do with how long they are. We were comparing them to each other, so if you're looking at those, comparing them to each other, you know they're equal distance apart, so they are parallel to each other. And our final example, I saved this for last because we do know these are intersecting. So if they're intersecting, we can't say that they're parallel. But can we say that they're perpendicular? Do they form a right angle here, a perfect L? No, a little too large. That's actually our obtuse angle. Do they form a 90-degree angle here? No, that's one of those baby angles, the acute. And opposite angles, when two line segments meet, would be equal. So this would be acute. This one would be obtuse. This does not have any right angles. So these would just be intersecting line segments. just intersecting. They wouldn't be perpendicular. It wouldn't be parallel. They're just called intersecting line segments. And that it does it. Hope to see you next time. Bye-bye.